In this video, I'll be helping you with the ALEKS problem type called Gauss-Jordan elimination with a 2x2 matrix. We're given a system of linear equations, and we're going to go through the steps to solve it by using matrix elimination. And we'll start by representing this system of linear equations in our augmented matrix. So our first column will be the coefficients in front of x, which is 4 and 8. Our second column is the coefficients in front of y. Being careful with the signs, these are -12 and -29. And then the third column is the constants on the right-hand side, 8 and 6. All right, so we have our augmented matrix. We can start to go through the process of turning the left-hand portion into the identity matrix. And you can see that our first step, we want to get a 1 in that upper left-hand corner. So we want to turn this 4 into a 1 by only multiplying the row by a coefficient. And I can see here that if I multiply by 1/4 everything in row 1, then 1/4 times 4 gives us the 1. 1/4 times -12 gives us a -3. And 1/4 times 8, a 2. For the second row, I haven't made any changes at this point, so I can just copy those in, 8, -29, and 6. From here, our next step is going to be using row multiplication and row addition to eliminate this element, the 8. I would want to take that top row, multiply by -8, so that I get that -8 times 1, which is a -8. -8 times -3 is a +24. And -8 times 2, a -16. This row, after the multiplication, is going to be added to this bottom row and replacing it. -8 plus 8 equals 0. 24 plus a -29 gives us a -5, and -16 plus 6, a -10. And again, in that top row, I haven't changed anything, so I still have -3 and 2. So this is our new matrix. From here, our next step is to multiply this bottom row by a coefficient that turns this position into a 1. And to do so, I'll need to multiply by -1/5. That multiplication, -1/5 times 0, gives me a 0. -1/5 times -5, a 1. And -1/5 times -10, a +2. So this last row is now 0, 1, 2. And our top row hasn't changed in this step. It's still 1, -3, 2. Lastly, we want to get the 0 in that upper right-hand corner, which means I need to turn this -3 into a 0. First, by multiplying the bottom row by something that will allow me to add and cancel out the -3. So here I will need to multiply by a +3. Multiplying that bottom row, 3 times 0 is 0. 3 times 1 is 3. 3 times 2 is 6. Now adding these values to the top row, 1 plus 0 is 1, -3 plus 3 is 0, 2 plus 6 is 8, and the bottom row I didn't change, it's 0, 1, 2. So we now have our final matrix. For the row that has a 1 in the x value, the right-hand side is 8, so 1x is 8. And in the row where we have a 1 in the y column, that would give us 1y equals 2. So y is 2. We've solved for both x and y using matrix elimination.